Hi guys, welcome back to our data science tutorial series. Today we are diving into one of the most exciting aspect of machine learning, which is supervised learning. We already discussed in our last video. So whether you are trying to predict house prices or classify emails as spam, supervised learning is the foundation of many real-world applications. Let's break it down. So I'm also write it here. Supervised learning involves training a model using labeled data. That means we give the model input and the correct output during training. So it can be learn the relationship between them. Okay, so the first one is linear regression. So the first one we discuss regression analysis. Under regression analysis, okay, now under regression analysis, first we discuss about linear regression. First up, we have a linear regression. It's used to predict continuous values like house prices, the relationship between independent variable like square footage, and the dependent variable price is modeled as the straight line. So we learn it using example. So here's how we can implement linear regression in Python using scikit-learn. So in this example, we use the scikit-learn library. First, import numpy as np. The second one is import pandas as pd. Okay, the third one is from sklearn dot model selection import train test split. Now the next one sklearn dot linear model import linear regression. Okay, the last one is sklearn dot matrix import mean squared error. Okay, now run this code. Okay, so it's working fine. Okay, now here we create our data set. Okay, so declare a variable which is a data pd dot data frame. Now the parenthesis. Okay, so the first column is square feet. Now define our variables values. The first one is 750, the second one is 800, the third one is 850, 900, and 1000. Okay, the second column is price. Now enter the values 1 lakh 50,000, 1 lakh 60,000, 1 lakh 70,000, 1 lakh 80,000, and the last one is 2 lakh. Okay, now here we define the featured and target variables. Okay, the first one is x, which is an independent variable. So for this, here we use a two-dimensional array, which is square feet. Okay, now the dependent variable, which is y, which is equal to, here we use price. Okay, now splitting the data. So for this, declare a variable train. Then the second variable is x test, or the third one is y underscore train. The fourth one is y underscore test, equal to, now train test split, open and closing bracket, x y comma, what should be the test size. So test size, here we define 20%, so which is a 0.2, and random state equal to 42. Okay, now after this, model training. Okay, so model equal to linear regression. Now use model dot fit x underscore train y underscore train. Now the next step is a prediction, DICTION. Okay, so declare a variable y underscore PRED equal to model dot predict. So here we use the test variable, which is x underscore test, because we test our prediction. Okay, so print predicted prices y underscore. Now the last one. Okay, now after this, we use evaluation. So for this, we use mean square error equal to mean squared error bracket. So it will take two arguments. The first one is y underscore test. The third one is y predict. Now print mean squared error is MSE. Now run the code. Okay, we underscore. Okay, so the predicted price is 90,769, and the mean squared error is, as you can see in the message box. Okay, so the predicted price is 160,000 and the mean squared error is 0. Okay, our next one is logistic regression. So here we discuss as an example. So here's a simple example of a logistic regression is, so for this, we use sk learn dot linear model import from logistic regression. Okay, now here we use a binary classification dataset. So data, the new column is above 200k equal to data, the column name is price, which is greater than 2 lakh. Now x equal to data two dimensional array, and the column name is square feet. Now y equal to data, and the column name is above underscore 200k. Okay, now train the model. So for this, declare a variable logistic model equal to logistic regression. Okay, now log underscore model dot fit. Here we use the variable x underscore train. The second variable is y underscore train. Okay, now prediction. So log underscore predict equal to log underscore model dot predict. So the variable is x test. Now print predicted class comma log underscore print. Now run the code. Okay, so the predicted class is 1,50,000. Okay, now the next one is classification algorithm. Okay, so algorithm, under classification algorithm. So here the first one is decision tree. Decision tree are like flow charts that split data into branches based on condition. So they are simple and interpretable. Okay, now we write a code for it. Again, we use from sk learn dot tree import decision tree classifier. Okay, now model training tree underscore model equal to decision tree classifier. Now tree underscore model dot fit x underscore train y underscore train. Now prediction. Okay, tree underscore prediction, which is a variable tree underscore model dot predict. So the variable is x underscore test. Now print decision tree predictions tree underscore. Now run the code. The decision tree prediction is 1,50,000. Okay, our under classification algorithm, the second one is random forest. Random forest improves decision tree by creating an ensemble of multiple trees and averaging their predictions for better accuracy. So for this again we use from sklearn dot ensemble import random forest classifier. Okay, now again train the model forest model equal to random forest classifier forest model dot fit. Now here we use the two variables. The first one is x train and y train. Okay, now prediction. So forest model equal to forest underscore predict a new variable forest underscore model dot predict x underscore test. Now print random forest predictions forest underscore pred. Now run the code. Now again random forest prediction is 1,50,000. Now the last one is support vector machine, which comes under classification algorithm. Support vector machine, also called SVM. Okay, now we have SVM, which finds the optimal boundary to classify data points. So again, for this we use from sklearn.svm import svc. Now model training. So svm underscore model equal to svc. Now the next step is svm underscore model equal to dot fit x underscore train y underscore train. Now prediction svm underscore predict equal to svm model dot predict x underscore test. Now print svm prediction svm underscore prediction. Okay, now here svm prediction changes the value, which is 1,70,000. So today we explored the basics of supervised learning, covering regression and classification algorithms from linear regression to svms. These tools are incredibly powerful for a wide range of problems. Make sure to try this example yourself. You will find the link of this file in the description. So don't forget to like, subscribe, and share this video. See you in the next episode.